Watching a tube QT line in action is a true showcase of industrial engineering. Steel tubes move down the conveyor and are heated to precise temperatures inside massive furnaces. The glow is intense. Then, in a flash, the tubes are rapidly quenched with water jets, locking in strength. Next comes tempering, where tubes are reheated to relieve internal stresses and achieve perfect balance between hardness and flexibility. Automated rollers guide each tube for uniform treatment. It's impressive to see how every stage, heating, quenching, tempering, shapes the steel's final properties. This careful process ensures the tubes can handle extreme pressures in their future applications. There's a certain fascination in watching a classic light bulb reinvented with modern LED technology. The production of an LED filament lamp begins with the assembly of tiny LED chips, each precisely positioned onto a supporting substrate. These chips are then welded into filaments, forming the elegant lines that echo vintage incandescent bulbs. The skill required here is remarkable. Each filament must be perfectly aligned for optimal light output. Next comes the critical step of coating each filament with a layer of phosphor and glue. This not only transforms the harsh blue LED light into a warm, comfortable glow, but also helps secure the delicate structure. The filaments are placed on special racks and subjected to high-temperature aging, an intense test to ensure reliability and performance. Afterward, the filament racks are welded and tested, confirming that every connection can withstand the demands of daily use. Each set of filaments is carefully inserted into a glass bulb, which is then sealed tight. The process doesn't stop there. Each bulb undergoes a vacuum treatment, with gases like helium added to improve heat dissipation and longevity. Once the bulb is prepared, technicians assemble the electronic drive circuit that powers the lamp, testing and welding the connections for stability. The final step is attaching and welding the metal base, providing both electrical contact and mechanical strength. The finished lamps are placed through a rigorous aging process, where they burn for hours to verify performance and catch any defects. Watching this blend of precision, engineering, and artistry, you can't help but appreciate the innovation behind every LED filament lamp. It's the marriage of tradition and technology, lighting up the future while echoing the past. It's incredible to witness a solid 386-pound billet of aluminum transformed into a legendary 427 Fe engine block. The process starts with mounting the raw block onto a massive CNC machine, where precise programs direct every cut. The first machining operation sculpts the back of the block, removing huge amounts of material to reveal the basic shape. Then, the block is repositioned for the second operation, focusing on the front and setting up all major faces and holes. The air in the workshop is filled with the rhythmic pulse of coolant spraying and spindles carving aluminum. A fourth-axis rotary table allows the machine to rotate the block for even more complex geometry, carving lifter walls, mains, and intricate oil galleys. Engineers noticed some end mills rubbing on vertical surfaces, so custom tooling was created for flawless results. Machining the main oil galley and boring each cylinder requires absolute accuracy. The team uses Darton cast iron sleeves for wet liners, similar to those in modern F1 engines. Throughout, quality checks are constant, measuring every critical surface. Watching this, you realize just how much skill and creativity it takes to engineer a high-performance engine from a single billet. Every pass of the tool brings the block closer to life, each cut filled with anticipation. By the end, what was once a raw chunk of metal now holds the spirit of speed, ready for assembly and track action. There's a special kind of satisfaction in watching raw steel transform into a tool built for a lifetime of work. The Golden Elephant all-steel shovel starts its journey with thick steel sheets, precisely cut into shovel blanks. Each blank passes through powerful presses that stamp out the recognizable shape of the shovel head: wide, strong, and built to dig. The next step is sharpening. Automated grinders shape the blade's edge until it's sharp enough to slice through tough ground. Every pass produces a shower of sparks, a sign of the steel's resilience. It's incredible to see the uniformity, with each edge meeting the same standard. Watching dozens of blades being sharpened at once is a true display of industrial artistry. After sharpening, the shovel heads are heated to red-hot temperatures for quenching, rapidly cooled to harden the steel. Technicians check each head for proper hardness, sometimes using drop tests or surface inspections. Only shovels with perfect quench quality move forward. The glowing red steel hissing as it meets the quench bath never fails to impress. Next, the heads undergo tempering, a crucial step where controlled heating relieves stresses and gives the blade the right balance of hardness and toughness. More quality checks follow, ensuring each head meets the factory's exacting standards. Now it's time to clean. The shovel heads are bathed in acid to remove scale, leaving a smooth, ready-for-paint surface. Meanwhile, the steel handles are cut and prepared. It's fascinating how the process forges not just strength, but also a flawless surface for finishing. In a dedicated area, grips are formed, shaped for comfort and control, then joined to the handles. Assembly brings all the elements together. The head and handle are joined by robust welds, creating a seamless steel tool. Every weld is inspected to prevent hidden flaws. Skilled welders move quickly yet deliberately, their hands steady as they make the final connections. Next, shovels move to the painting line, where a durable finish is applied, protection against the elements, and a signature of the Golden Elephant brand. Before leaving the factory, every shovel faces a series of rigorous tests. Size and fit are verified, and each one is loaded, bent, and even dropped to ensure it won't break or deform under heavy use. Only shovels that pass every challenge earn the Golden Elephant mark. The result is more than a shovel. It's a trusted companion for gardening, construction, and demanding jobs everywhere. Seeing each step unfold makes you appreciate just how much effort and skill go into something that lasts a lifetime. Multi-layer pipe production doesn't get more advanced than the MFWL-20 line. High-output extruders feed precise layers of polymer and metal, forming pipes with 3 or 5 layers in seamless succession. Ultra-thin aluminum or stainless steel tapes, down to just 0.12 millimeters, are gently shaped, then joined using laser welding with orbital seam tracking for flawless welds. Every weld is monitored in real time to ensure integrity. Integrated controls keep every stage in sync, minimizing waste and maximizing efficiency. Watching meters of pipe roll out with perfect structure and quality is a testament to modern engineering. This line truly sets a new standard for multi-layer pipe manufacturing. Laser cutting machines slice through thick steel plates, producing flawless arches for semi-trailer frames. Each automated pass delivers smooth, burr-free edges, minimizing material stress and ensuring every component fits with impressive accuracy. Witnessing a 40mm stainless steel plate bend into a precise U-profile is truly impressive. This 3.5-meter-long austenitic crossing-knee steel sheet meets the massive force of the press brake, shaping perfectly with every stroke. The smooth, even bends show just how powerful and accurate modern metal forming technology has become. Precision metalworking comes to life in this Walter Tools WFL demo, a showcase of what modern machining can achieve. The process begins with a solid 42 CRM04 steel workpiece, 150 millimeters in diameter, loaded onto the versatile WFL multi-process turning milling center. First up, the TigerTech Silver DNMG insert takes roughing cuts at speeds up to 320 meters per minute, efficiently removing material while maintaining a steady feed of 0.15 millimeters/rev. You can almost feel the power as the lathe shapes the steel with each pass. Then, the Extreme Step 90 drill comes in, drilling clean 10.2 millimeters holes with chamfers at 110 meters per minute, its power grip holder ensuring rock-solid stability. Watching the drill plunge effortlessly into hardened steel is a real testament to both the tool and the machine's rigidity. Threading follows, with the Supreme TC611 tap forming precise M12 threads into the hardened steel at speeds up to 110 meters per minute. Seeing threads cut so smoothly is truly satisfying. The Extratech and TigerTech Silver milling tools now machine shoulders, slots, and complex features, each one measured in microns. Throughout the process, orbital and deep-hole drilling cycles are performed, followed by eccentric machining, all without removing the workpiece. The ability to switch between turning, drilling, and milling on one setup is a marvel of engineering. There is a certain thrill in seeing chips fly and profiles form with such controlled power. Advanced laser measurement and inline quality checks guarantee every surface meets spec. Tool changes are swift, with shrink fit and hydro expansion chucks providing both rigidity and accuracy. The metal chips fly and the coolant sprays. Every second on this line is a blend of speed, precision, and control. Even the sound on the shop floor, steady whirring, quick tool changes, and bursts of coolant, reminds you how alive this environment is. At every step, machining parameters, cutting speeds, feeds, and depths are tightly controlled. By the end, the component emerges flawlessly finished, its complex geometry achieved in a single clamping. Watching such a process in action makes you appreciate the engineering and teamwork behind every perfect metal part. With the right tools and strategy, production efficiency and accuracy truly reach new heights. Kitamat's aluminum plant uses advanced smelting cells powered by renewable hydroelectricity. Modernization boosted capacity 50%, now reaching 420,000 tons yearly, while cutting total emissions in half. Clean technology here sets a new benchmark for global aluminum manufacturing. High-speed wire mesh welding is on full display here. This machine reaches 120 welds per minute for 3D panels, construction mesh, and shelf racks. Watching steel wires fuse instantly into precise grids is truly impressive engineering. Beneath Melbourne, one of the most ambitious infrastructure projects in Australia is taking shape, the Metro Tunnel. This massive undertaking features twin tunnels stretching 9 kilometers, connecting key destinations across the city. 5 new underground stations, Arden, Parkville, State Library, Town Hall, and Anzac, are under construction, each engineered for heavy daily use and future growth. Construction teams began by excavating deep below the city, carving out vast underground spaces. Giant tunnel boring machines methodically chewed through soil and rock, creating smooth, reinforced passages for high-speed trains. At every stage, strict safety protocols are enforced to protect both workers and residents above. Installing reinforced concrete linings ensures stability, while sophisticated ventilation and drainage systems keep the environment safe and dry. High-capacity signaling technology is being integrated throughout the tunnels, enabling more trains to run simultaneously and minimizing wait times for passengers. It's impressive to see how precisely every system is coordinated, especially in the crowded heart of Melbourne. These engineering feats will untangle the city loop and allow for more frequent services, changing the way millions travel each day. Seeing new stations take shape and entire neighborhoods prepared for improved transit is truly exciting. As the Metro Tunnel nears completion, Melbourne is set for a dramatic upgrade in connectivity, bringing faster, more reliable transport right beneath the city streets. Heat, steel, and the relentless pressure of heavy machinery come together in this cutting-edge ring-rolling process. Here, a newly developed, fully automatic machine tackles profiled idler rims, handling 2 rolling stages in a single, uninterrupted sequence. Massive cylindrical blanks are first heated until they glow, the surface radiating intense light as the metal reaches forging temperature. With hydraulic arms in place, the blank is positioned between the main roll and the axial roll. As the process starts, both rolls rotate and compress the hot metal, shaping the profile with remarkable consistency. The system's automation precisely controls pressure, rotation speed, and progression, ensuring each section forms to tight tolerances. No room for error here. You can see the seamless transition as the machine guides the rim through both rolling steps. Flames and flying sparks highlight the sheer force at play, while coolant jets help manage heat and keep the equipment safe. Watching steel bend and transform in real time is always exciting, but this level of process integration takes manufacturing efficiency to another level. The entire operation showcases a powerful blend of precision, speed, and raw energy. Hot rolling at AMNS Calvert is a powerful display of modern steelmaking. Massive slabs, heated to over 1,200 degrees Celsius, glide along the mill line as rollers shape them into precise coils. Automated sensors and powerful hydraulics ensure every thickness and width meets tight specs. Watching red-hot steel transform at such speed and scale is an impressive feat of industrial engineering.